All right. So this has confused some people. It's confused me a little bit. The shim angle of the rear stabilizer. Right now, if you get a brand new IQ foil set or a new foil set from Starboard, there is a marking that this is I've got it upside down, but it's a 255 centimeter squared wing. I found a little nick just now. And it is a -2 degree wing. I'm not sure entirely the origin of that, but I'll get to what I think it is. But the problem is, what I expect is a little bit opposite of what happens with a shim, and we'll see what I mean by that, hopefully. So this is the fuselage, and this right here is the 0 degree shim. And if you look at that, this trailing edge of the foil is almost flush, maybe rebated like maybe a millimeter or half a millimeter from the top of this because there's some curvature. But the leading edge, the center of the leading edge, the mean camber line, if this is symmetric, it looks pretty close to symmetric, is down lower than that. That means this wing has a built-in negative angle of incidence. And what is that? That just means, if we look at this diagram here, if this fuselage, if this front wing is aligned so that it is completely neutral with the fuselage, that means that the rear wing is actually facing downwards just a little bit. And that's what I drew in this diagram here, is this rear wing is actually pointing downwards a little bit. So this rear wing, if this is perfectly level, the board is perfectly level, we're assuming the mast comes out perfectly vertical, there's no rake in the mast. The board's perfectly horizontal as well, so that means this fuselage is parallel with the board. We're moving forward, we're not flying because the wing is parallel with the water flow, meaning the front wing is parallel with the water flow, meaning it's making a lift. The rear wing will make a small amount of negative lift, just like that. And that will tend to make this whole system want to rotate upwards, meaning the front wing now is going to want to push up on the board. But you'll also notice at some point this rear wing actually goes neutral. So it goes from making some negative lift to now being in line with the flow to some extent. And so it effectively doesn't create any more lift. There is some point that happens. There's some angle of attack. Now, when we go even further past that, this is such an extreme angle of attack, it would really only work at low speed. But at some extreme angle of attack here, not only do we get lift on the front wing, but we get lift on the back wing. And the front wing lift makes this want to rotate up further, and the rear wing lift wants to make it front of the board pitch down. Okay, so this angle of incidence, which I've marked here in the rear, is what changes that angle from where that rear wing goes from producing negative lift to producing positive lift. And it appears to me that happens to roughly 2 degrees with the -2 shim. But here's where it's confusing. These shims, I'm trying to put it on a book here so it's a little bit easier to see. These are the shims, and there's some minute differences here. And this one is a little bit bent, but you'll see this is the -2 shim, this is -1 shim, this is the 0 shim, and this is the +1. And these are all the rears of the fuselage. And you'll notice this +1, if you can tell from this lip right here, ignoring that bent one, the +1 wants to force that rear end higher. So that produces more negative lift, and you have to get up to more like maybe 3 degrees before the rear wing goes neutral. You go to the other extreme, so sorry, that's a +1 over here. Rear wing high. The other extreme is the -2, which you notice that actually it makes the rear side of the wing is low and the front end is high, meaning it's going to effectively make this rear wing here in line with the front fuselage, meaning as soon as you get any kind of motion or any kind of rotation here, this rear wing starts making positive lift and wants to then rotate it back down. Now, all this also depends on where your body weight is and the position of your straps and everything relative to this lift. But that's the essential of what these shims are doing. So right here, excuse me, let's look at this diagram again. With that wing, this is about where it comes in with a 0 shim. With the +1 shim, it forces the rear end higher. I want to exaggerate it so that with this in line with the flow, it gives you more negative lift and forces the nose up. When you get all the way to the -2 shim, it's essentially in line with the flow. The confusing part is that I would think that -2 wing would actually be labeled as a +2 because it's +2 degrees of incidence, or the shims would have their numbers flipped. But I think what Starboard did is either based off their past rear wing design, which I'm unfamiliar with, or they just wanted the positive numbers to mean more lift, meaning it forces the nose of the board up. And I think that's what it comes down to. The positive shim gives you more negative lift of the rear wing, which forces the nose up, whereas the negative shims, or the shims marked negative, gives you less lift, and that is the entire reason of that sign there. So there was a little confusion with me because this -2 kind of is counterintuitive compared to the shims. Now, people have asked on some forum somewhere, are these shims actually a degree? And from what I can tell, that's about the case. So we can do a little bit of math here, and we can measure. So you notice these have holes. For whatever reason, that -2 shim actually has more of a elongated slot there. But we've got these holes on the shim, and what I'm going to do is I'm going to measure as best as I can the center distance here of these holes. It's pretty close to 100 millimeters of the front hole to the rear hole. So we'll say the length is equal to 100 millimeters. And now what we can do is we can measure thickness. And this is the -1 shim, by the way. So the thickness I'm measuring on these calipers, it's a plastic, probably a molded part or something. It's not perfect. There's some curvature there. It looks like it's not bottoming out. But we'll say 4.2 millimeters. So that's the height of the rear. So we'll just say height of the rear, 4.2 millimeters. And we'll also measure that front. Same way. It is 5.9 millimeters. Height of the front. So this, even with this little kind of distortion from their molding process or whatever, there is a slight rise going from rear to front on the -1 shim. And that rise is equal to the h of the front, the height of the front minus the height of the rear. That rise is, we'll put in millimeters, 1.7 millimeters. That length between those bolts is 100 millimeters. And so what we can do is we can take the inverse sine of those dimensions to give what that angle actually is. So the rise over the length, and that's in rad. But what is it in degree? So that's 0.017 rad. Look at that, 0.974 degree. So within some amount of manufactured precision, this -1 shim is in fact a 1 degree rise in the angle of incidence of the rear wing, meaning it forces the nose of the board up less.